are going to be talking about the dRTC universe. You're just getting a quick sneak peek over there already. But the dRTC universe, we're going to be talking about the aspects that we can unlock with rapid data transfers, with really low latency data transfers. What kind of use cases can we actually unveil beyond communication? So we're going to be exploring two themes today: connectivity beyond communication, and as well as coordination that we can bring about with very efficient communication. I'm Shruti Appiah. I am the chief economist at Huddle01. It's so lovely to see some of my contemporaries here. I think Amanda was just here speaking about her early times at Consensus. And I'm so glad to have experienced the same too back in 2016. This is the recent explosion of technology. We've seen exponential growth in computing power. We've gone from basic analytical engines that can just mechanically make computations, all the way to right now we're actually grappling with the idea of a singularity that is enabled by AI, as well as humans and AI that are interacting with each other. But let's take it a few steps back and see what we actually started from at the start of human civilization. Initially, we started off as just biological human societies. Our capabilities were largely limited by biological and physical constraints. We were terrestrial organisms, and we only had the ability to communicate in a very local fashion. And then we started inventing tools and machines, and that way humans started to delegate some of their tasks, more simple tasks as well as mechanical tasks, over to machines, and then we turned into a more of a human plus machine society. Following that, as machines became more advanced and we started to also give them the ability to make some level of decisions as well as handle more complex tasks by themselves, we started to enter the human and robot society. And so if you look at the progression of all of these things, you can think of human society, just the biological human society, as what started from very early civilization all the way to the agricultural revolution. Then we had the human to machine society that started all the way from this time that we started developing tools all the way until the Industrial Revolution. And then we started to progress into a more semi-autonomous world where we had robots actually aiding some of the decisions that humans were making. Now we're actually grappling with the next stage, which is human and AI agent societies. And this is quite interesting. So now we're not just delegating very simple mechanical tasks over to the machines. We're also going to be dedicating decisions as well as giving agency to machines. This is a very big step from what we had previously. Previously, we were just delegating tasks, and tasks aren't necessarily intelligent, whereas now we're delegating agency. We're delegating the ability for machines to make decisions for us. And so I really wonder what this will look like. And, in order to actually enable a very positive way that this should happen, we need a way for these machines to talk to one another. Multi-agent coordination, and these agents can be anything. They can be anything from edge devices. They can be humans. They can be machines. They can be AI agents. Multi-agent coordination amongst all of these agents requires synchronization. And you know what gives synchronization? It's the dRTC network. The dRTC network is a decentralized real-time communications network that has been enabled by Huddle01. When we're thinking about something such as decentralized AI, it actually comprises, in its architectural sense, it actually comprises of quite a few different ingredients. You can pick and choose from one of these. It has edge devices that are, performing their own compute. It is also acting as a sensor. So you also have IoT sensors that are inputting information into the system. And you also got human sensors, perceptors, as well as predictors. Can someone perhaps have a guess at what this might be? A system where human sensors are making predictions? Anyone? The human brain, yeah, that's fairly accurate. What about in a collective way? Well, I'm going to tell you guys the answer. It's going to feel really obvious. Well, it's a prediction market. So there we go. These prediction markets also feed information into the system by sensing what's actually happening. Humans are actually sensing what's happening out in the real world, and then they're perceiving it, and they're making predictions about the future, and that's essentially a prediction market. And finally, we've also got edge compute nodes, which have AI inference capabilities. And so that's definitely the main one that we want to focus on here, and the way for us to be able to have these different AI agent nodes to be able to communicate with one another and to be able to sync with one another. In order to do this, we require many extremely low latency as well as low cost and high bandwidth remote communication. You can expect that these nodes are going to be geographically distributed all over the world, and we can also expect that they need to make very frequent communication, and these communications will require micro levels of data, and it needs to be very low cost for those reasons. And so if we want this rapid, low cost way of actually transferring data across the world, maybe across space too, then that's where the dRTC network comes into play. With the dRTC network, we've already enabled us to be able to connect with one another to audio-video calls, such as with Huddle01. Now, why don't we explore not just human-to-human communication, but also machine-to-machine as well as human-to-machine communication? The other application that this could have is around industrial automation as well. When we've got a extremely supercharged decentralized AI system where all of the different elements and the agents within that system are independently computing and sensing themselves, this allows for them to be able to make decisions independently in a very low latency manner as well. In order to have all of these agents actually communicate with one another, we require there to be a system for these guys to actually talk and share data. And that's where the dRTC network actually comes into play. It enables extremely low latency ways of communicating across these agents, and that helps us have these AI agents not operate in silos and rather share information, share learning as well, and unlock various types of topologies as well. And certainly, like, one of the nice side effects that this brings is whenever you build any sort of decentralized system, you're able to experience a ton of robustness as well, because just the fact that this is decentralized lends it to be much more operationally resilient. So the dRTC network plus edge computing AI, where you've got tons of AI agents, which are basically edge computing nodes, this actually unlocks a myriad network topologies as well. Because now what you've been able to do is you've been able to take something that was really expensive to do back in the day. Well, actually today it's very expensive to be able to run decentralized AI, because you need all of these nodes to be talking to one another very frequently in a super low latency manner. And this is all really expensive. Cyber infrastructure in general, such as compute, storage, bandwidth, in order for these data transfers to happen, those are very expensive commodities today. And so if you want to actually transform this entire system, the thing to unlock is necessarily just the real-time communication aspect, so that these agents are able to talk to one another in a really rapid, low latency fashion and a low cost fashion as well. So let's explore some of the network topologies that we can unlock with dRTC network. So right now, most of the things that have been built, they sort of operate in a centralized or maybe in a hub or spoke fashion. In a centralized fashion, all of the nodes that are on the edges of the network, they have to be speaking with the centralized data aggregator, which is essentially that is the one that actually performs most of the learning and also holds the AI algorithm. It needs to be coordinating with that quite a lot, and for that reason, all of the transactions related to that tend to be fairly expensive. Another kind of network architecture that becomes much more simple and cheaper to run is essentially the hub and spoke model, where it's still somewhat centralized because you've got like centralized nodes, but it's at the same time it's decentralized in the sense that you've got these smaller centralized networks in different areas or for different categories. And the hub and spoke model becomes fairly feasible as well, and both from a cost perspective as well as from a latency perspective. You can have basically these central nodes to be much larger servers, and so server to server communication is generally a lot cheaper and faster to do than client to server communication. So the hub and spoke model with the dRTC network becomes super easy to achieve, and it's actually what we have implemented today as well with regards to cascading. Another one that I'm super interested in that this also enables is to have local networks of different nodes, and these local networks can actually talk to one another as well, and so that way you're able to get some of the advantages of centralization or localization while at the same time not necessarily operate in silos. And so all of these groups of networks can actually transmit data between themselves and also learn from the other networks as well. So, some of the applications where you might see this is essentially with drones, swarms of drones, swarms of robots that are operating in different regions and require some sort of synchronization between the different swarms as well. And finally, also very interestingly, you can also enable concentric networks or multiplex networks as well, and where you have many layers of the network that are independent of one another, but they are also speaking with one another and transmitting data between one another, data as well as learnings. And finally, if you want to use the maximum, if you want to take the maximum advantage of decentralized real-time communication with super low latency with low cost as well, then you can implement a distributed multiplex network, which is really, really fun. The third thing that this can enable is essentially to make applications autonomous as well. We can have AI-driven smart contracts where AI agents are essentially driving the decision-making for a lot of the rules and the logic that is embedded within smart contracts. So these smarter and more autonomous applications that we'll eventually end up building with this kind of AI-driven smart contracts model will essentially operate without any central control, thereby making our lives much easier so we don't have to actually interface with the app as much as we needed to before. And so apps with AI at the edge can actually make these decisions independently without requiring any human or manual input, and all of these decisions will anyways be made with the constraints that are set by the smart contract. Applications of this, as Ayush was speaking about earlier, is hyper-financialization. We can actually make tremendous amounts of improvements, especially with regards to high-frequency trading as well, because low latency is one of the most crucial elements to enable us to be able to capture these arbitrage opportunities. And we can do this as well on decentralized exchanges too. You can also do for supply chain and provenance systems. And also you can do things such as dynamic content moderation for social media platforms that is just handled altogether by artificial intelligence. So it doesn't require so much human work because these agents can make decisions. I want to, I put a picture of Bertrand Russell here. He's one of my favorite philosophers. This is not his quote, but I want to explain how we are actually entering time when we're going to be playing more and more positive sum games. As we're entering a spacefaring world, we're increasingly playing positive sum games because resources aren't constrained. Cooperation always triumphs competition. when we have an abundance of resources, when we have spacefaring civilizations where we're also surpassing the amount of energy that we can actually harvest. So just think about it this way. What is the system that you want to install? And I invite you to join me on this imaginative journey for the decentralized network, which is essentially going to be a coordination mechanism for multi-agent spacefaring civilizations. Take care, folks. And one thing, I should not forget this, we're actually going to be running a dRTC and AI workshop at ETH India. So definitely check that out. And this is my contact. Thank you, folks.